talk a little bit about my experience on our final project. The algorithms I choose is the longest common sequence. The two solutions I implemented is the dynamic programming and the brute force. So as for dynamic programming, the first we need to create a matrix and do some required calculations for a matrix. After that, we can find out the longest common sequence from bottom to up. As for brute force, first we would like to find out to iterate all the subsequence of the input x and check each of the subsequence is also the subsequence of the input y. And then we keep the longest subsequence in x and y. Okay, let's look into our code of the implementation. So as you can see, this code is implemented by Python, and the format and the structure is following to the pseudocode, no matter the DP or the brute force. Okay, so I won't talk a lot about the implementation for the algorithms. If you are interested in this part, you can refer to our reference book or our lectures. And next, I will talk about my experience in running these two algorithms. So because for the longest common sequence, it has two inputs, input x and y, the sequence x and sequence y. And I would like to check how the length of the x and the length of the y will impact the running time. So I actually set up 6 running cases. The first 2 cases is about checking the impact of the x and y, the length of x and y on dynamic programming. So I have for case 1, I have the fixed s length and changing the length of y, and as for case 2, I have a fixed length of y and change the input length, the input s length. As for case 3 and 4, I apply the same idea into the brute force. And as for case 6, I also apply the same idea into the same idea with the same input to the algorithms 1 and the algorithm 2, this dynamic programming and the brute force, to make sure we have a better comparisons in these two algorithms. So let's see how I did this. So first, I defined the size of the length. The first parameter will control the input length of x, while the second parameter will control the input length of y. And this is the first case I only run dynamic programming, and this is the case 2, case 3, case 4, and here as for case 5 and 6, I use the same input to run these two algorithms at the same time, and let's see how we will do it. So this is the size is to control the input of x and y. This is the functions, and this key is to use to save the data into a CSV file. Okay, let's see how I did it. So here, for each of the size, I will run 10 episodes. And let's see. I run. Let's go. So here, first I took out the size from the sizes, and here we have the first size control the length of x, and the second size will control the length of y, and then we generate a random string for x and y, and then we run 10 episodes for each of the function, and run the experience. Okay, so run the experience is quite easy. I call the function to find out the sequence, and then calculate their running time, and then save the running time into a list. As you can see here, actually I save the results for each of the sites once it has finished. You can regard this is the checkpoint. And then once all has been done, I will save all the running experience into the file. Let's start with all, and then calculate the average based on the all algorithms. So I use the NumPy min function to calculate the running time average, the average of running time, and then the final result will be saved into a file. Let's start with the AVE average. Okay, let's see how it will be run. Okay. So here I print some of the progress here. So as you can see, the first one it runs with the bottom up with the size x size, s length is 20 and the y length is 10, and its running time will be about 0.2 nanoseconds. And as for brute force, with the same input size, it's much higher. The running time is much higher. It takes about 6 seconds. Okay, so I run it for 10 times. Let's see, 00111 until this is A, and it will be done soon. As you can see, actually, the running time for the bottom up over the 10 episodes, they are quite similar, even if varies, but and let's say for the brute force is around 6 seconds. Yeah, it's all around 6 seconds. And then okay, the first size has been done. It starts run the second size. Okay, let's see as the results should be saved. Okay, anyway, so as you can see, I save all my running results for the 6 cases. It starts with the all for all the running experience and average for that has been calculated over the 10 episodes. Okay, so now let's look into how I draw the figure. I use the Jupyter to draw the figures and then save into the folder figure here. I have 6 figures. Okay, as you can see here, the checkpoint file has been saved. Once all the data has been finished, let's use a smaller data to see how it will work. 10. Sorry. Okay, I think this should be done very fast. Okay, it has been done. All 3 files has been generated. Let's read into how we generate the figures. So first, this is the case 1, and I plot the imperial and the predicted running time. And for the second one is for case 2. So because the running time is dramatically changed, so I use the log 10 to scale the running time to have a better understanding. This is case 3, case 4. Yeah, this is the same. Use log 10 to scale the running time. And case 5, this includes the both the dynamic programming and the brute force are the same with different inputs. Yeah, that's it. Thank you.